right down the agenda, I guess, and we're going to move on to EJ Habrook. EJ came from Nebraska, so he made a little bit of a trip today. We appreciate him coming up. He's going to cover a little bit about KLine irrigation, what their equipment is and used for, and a few projects that he's currently working on.
Okay, KLine is an irrigation system that came out of New Zealand. It's been in the United States for 9 years. And a little bit about my background. With KLine, I was their first employee in North America. And basically what we've done is taken a product from their farming practices, their product, and we're modifying it so it works in the United States. The livestock industry in New Zealand is primarily grass-based, where ours is more of a forage-based and things like that. The irrigated pasture part, if you guys are interested in that, if you got water, get a hold of me. As far as the livestock waste, I think that's mainly what today is about. What they're doing here is they got a small feedlot. The runoff water is captured into this pond, and then it has to be land applied. What we've done in Nebraska is we're trying to get rid of the long-term storage lagoons. Because number one, they're very, very expensive. Number two, they're not very environmentally friendly. There's a lot of leakage and things like that, even if they're lined. We're trying to find a way for the small producers, meaning 1,000 head or less, so that they can afford to be environmentally friendly without being, run out of business as far as cost. If you put in a long-term storage lagoon right now, it's got to be lined. The cost per animal unit is about $192 per animal unit. The cost to decommission it when you're done is higher than the cost to build it. So what we've done is if you can capture the runoff water after a rain event and apply it within 96 hours of the rain event, you don't have to have a lined lagoon. So basically what we're doing is the same thing you're doing here. We'll put a berm around your feedlot because we only want to capture the water that runs off the feedlot. We don't care about the rest of that water. So we'll put a berm around the feedlot. We'll catch the water that comes off it. It'll run through kind of a filtering, not really a filtering strip, but a waterway going into a small lagoon such as this. It's not a lagoon because the lagoon is long-term storage. It's more of a holding pond. What we'll do then is we'll have a small pump, and we'll pump that out through a pipeline up to some hill ground or some ground farther away from a stream or a place where it would run off, and we apply it no faster than the infiltration rate of a saturated soil. So we're down to about 1/10 of an inch an hour. That area is called a vegetative treatment area. Now, there have been vegetative treatment areas in the EPA guidelines for a long, long time. The problem was that they were all gravity, or they were solid set sprinklers, which required a lot of maintenance, a lot of upkeep, and they didn't like them. And what we've done, that's why the EPA quit approving them, because if they're flood irrigation, you got to get the water, you got to saturate the soil before the water moves down. You have a tie-up of nutrients in this area. So what we're doing is we're just taking KLine, putting it up there, applying it very, very slowly. You'll have, for every acre of feedlot, you'll have about 1.2 to 2 acres of an area that is just in grass. That grass cannot be grazed. It has to be harvested and fed back to the cattle. Because what goes in the front of an animal goes out the back or the bottom. If they're eating the grass and pooping there, we're adding more manure to it. So that's why we have to harvest it, and it's fed right back to the cattle in the feedlot. The lines are easily moved. What we've done by using our portable system is during the summer when you've got crops growing around it, you apply right in that area. In the spring and fall, you pull them out to the ground beside it, to the row crop area, so you spread your nutrients out over a bigger area. We've got the cost per animal unit down to about $72 per head. It's an approved practice in the state of Nebraska. I'm pretty sure it is in North Dakota. I'm not sure. If not, they can follow the guidelines. I can get you in contact with the people in Nebraska at the NRCS office. They all know about it. This type of lagoon here, your solids are going to settle out to the bottom. A lot of your nitrogen is going to volatilize. What we're finding out is if we capture the water right away and apply it, we're getting about 30 pounds of N per acre inch. And this stuff here would be very, very minimal. because it volatilizes. The other thing we're finding out is if we apply it right after a rain event, it doesn't have a chance to smell. We've really reduced the odor levels. So neighbors don't mind them. That's the biggest issue we're coming into in Nebraska is you've been feeding cattle, you're a third generation farmer, you want to do something, you want to expand, and the neighbor that works in town says, oh, that's going to stink. So you got to be friendly for them. But it's working very well.
How much labor does it involve? Like how much time are you going to spend moving sprinklers around or what?
That's the neat thing. Because if you set up on a vegetative treatment area, your pods will sit out there in between about 2 or 3 times a year. You'll unhook a camlock fitting, hook onto it with a 4-wheeler, pull it over, and reattach the camlock fitting. There's no labor to it. It's pretty simple. In wintertime, everything drains back. You take the plug out of the pump, and it's good to go. Problem with a traveling gun is, number one, you're waiting for somebody else to use it. Anytime you're renting something, you know it hasn't been greased or taken care of. There's a lot of labor to move and to set up. That's why there's a $600 charge. You can take our system with a portable pump and a floating screen, even if you have a pond like this, set up an area with KLine. That looks like a lot of water. There's really not that many. You know, everybody thinks, oh, I want to use it to irrigate. Well, give you an idea. If you're going to irrigate, 1 inch of water on 1 acre is 27,154 gallons. So yeah, that looks like a lot of water, but that's probably going to put 1 inch of water maybe on 5 acres. So you don't get the bang for the buck as far as irrigation. But if you got a good sized pond like that, you could set up an area and irrigate a few acres. For your bigger feedlot guys, the problem with using a center pivot is unless you flush them out with water, the galvanizing does not last very long. That's the nice thing about KLine. So totally non-corrosive. It's all poly-based product. So there is no flushing, there are problems like that. There are a couple of small systems in North Dakota used for irrigated pasture. Your research center in Mandan, they've got a KLine system in for irrigation, but not for livestock waste.
The equipment, how's that going to hold up, or how many years are you usually going to get out of it? Is it something you need to pull inside during the winter time? Or?
Wintertime, you just take the end cap off and drain the water out of it. The tubing, we don't know how long the tubing's going to last. It's a product that we came up with. New Zealand's got the second highest UV ratings in the world. The original line's been in for 20 years and have not been replaced. Since it is on the cost share docket, the government does not like to cost share on anything that is not proven to last 15 years. We have our own separate ASTM numbers on it, which is a manufacturing standard from an independent laboratory. Our tubing now is all ASTM stamped. It will last the 15 years.
The pump, do you provide your own pump, or is that on the producer?
We don't sell the pumps, but I will put you in contact with people that do.
So is that pump cost in that
Yeah, that's $72 an acre, or $72 an animal unit. That includes all the dirt work, the pump, the application equipment, the pipelines, everything. If you're going to feed cattle, it's a good way.
So the area that you're working in right now, what's the average rainfall there, and what's the typical rainfall event?
What we do is we set them up for a 25-year rain event.
Okay.
Where I live, our average rainfall is 28 inches per year.
Okay.
When we get into western Nebraska, it drops down to about 18 inches a year. But each one of them is designed by the NRCS office. Each one of them is designed for that area.
How about the spring melt?
We'll apply that. What we end up with in Nebraska quite often is a January thaw. And these systems are set up so that you could apply it if the ground is thawed. Nobody wants to see this water applied on frozen ground. When the ground is froze with a vegetative treatment area, since you don't have water in it, what you'll do is you'll scrape that once or twice a year to get rid of the solids. And that is land applied, farther away. In the wintertime, what is collected in there is on frozen ground and it stays there. When the ground thaws out, you turn on the pump. But if you do get into a spot And it doesn't happen very often, but every few years we will get a January thaw. And the ground will thaw up. And then at that time, we will turn it on and run it and get it pumped out.
Well, you're talking about, what, 96 hours afterwards?
Mm-hmm.
Well, that won't apply for a spring melt. I mean,
Yeah, it will. Yeah, it will. There's not that much water.
We've had a lot. Our feedlot melts way faster than the field does. There'll be a snow cover yet.
Right. But you also got to realize that we are removing the snow out of our feedlots. We are trying to minimize as much moisture in there. And I know that sounds like a lot of work. The expensive part of manure is not hauling the dry. The expensive part is getting rid of the liquid. So if we can get rid of the liquid, the value is in the dry. And our feedlots, predominantly, most feedlots, they will scrape and load the snow out. But in the spring, when it's thawed, yeah, you can run them. The unique thing, as a producer, I'm going to throw this out to you. Nobody likes listening to a researcher tell him how to do something. But what's funny about this is every one of these systems that we put in, it's usually somebody that knows that they have a problem and they want to solve it. And when we first go out there, you see what you see in normal feedlots. You see a low area where there's mosquitoes, there's bugs. It's poorly managed. One of the things that we've done with this program is we've worked with the producers and educated them. And the university people I've been working with, they don't like wearing dress slacks and shirts. If I showed you some of the pictures we've taken of them, when I show it to my people in my office, they'll look at them and say, well, who's that hick? This guy's got a PhD, and he's sitting there with bib overalls on and an old hat. That's the type of guys they are. But they've experienced. They know what they're doing. What we found out is, and every producer will tell you this, that by going through and with us working with them and showing them stuff, that in a year or two, all of a sudden the problems they were having in the feedlot, as far as sediment and things like that, are gone. By scraping the feedlots a little more often, they don't have the mud issues. They don't have the fly issues. They have a little bit better rate of gain. There's a lot of advantages to a well-designed feedlot.
You had mentioned you're working with the swine operation currently. Do you want to talk a little bit about that, what you're doing there, what they're working on?
Most swine operations, most livestock operations are built with, okay, we're going to catch the manure, but that's the cheap part. From there on out, it's the expensive part, because manure is a waste. Even though it's got value to it, it's a waste. Found a hog unit in Missouri that's got a grass-based area attached to it. And their underbuilding manure goes out into a small holding pond. It's not it's just a captive pit is what it is. We put a pump in it. The guy had 3-inch underground buried throughout 200 acres. And he had a traveling gun with a big pump and everything else, and he was applying with the traveling gun. The problem with the traveling gun is he was getting runoff and everything else. Now remember, I told you before, if you capture the runoff water off a feedlot, you'll have about 30 pounds of N per inch of water. Hog manure, when you capture it right out of a building, there's about 30 pounds of N per 1,000 gallons. So you can only apply about 1/3 of an inch per year per acre. So what we did was he had the underground all buried. We took the same pods, everything, hooked it up to his risers out in his field, and he leaves them sit for about 1.5 hours. We're putting on about 1/10 of an inch an hour. He leaves that line sit for 1.5 hours. He uncouples it, pulls it over, recamlocks it, and he's applying his manure throughout the 200 acres of pasture. He's got about 10,000 head of hogs on feed. And those 10,000 head are basically applying, they're generating all the nutrients he needs. What I found very, very unique in it is most companies that come in and will take your manure and lay out the pipelines above ground and knife it in. The cost to do that in 1.5 years paid for his underground system, the pump, and the sprinkler system. The other thing we have to look out for is when we're land applying it on grass that's growing, is you need to leave it sit for, depends on where you're at and things, but you need the sunlight to get rid of the E. coli and things like that. Sunlight is a great way to get rid of E. coli. But what he's doing is, it's supplying all of his nutrients to his pasture ground. He's got grass that high. He's got about 120 cows. He needs more cows because he's got more grass he knows what to do with. He's actually baling and selling a lot of it.
So you can spread manure through it, also liquid manure, not just water.
Yeah.
What does he do with the sediment?
With the solids and stuff. We found a company that makes a filter. We're putting that on the intake side of the pump. We put an intake screen to the size particle the pump can pump. On the discharge side, we're putting a small filter. Instead of having a screen in it, it has a stainless steel cylinder in it. It's got holes drilled in it. We size the hole in the cylinder to the size of the discharge of the sprinkler. And it's kind of funny, as the manure gets in there, it spins around and it actually acts like a particle sizer. We've got one system. We pumped 385 gallons a minute for 48 hours. When we opened it up, we had a handful of fly heads, and that's what would have plugged all the nozzles. But that's all we had in there. A well-managed long-term storage pond, and I mean well-managed, the end of 20 years, which is their life expectancy, there should be less than 18 inches of solids in the bottom. Now those solids in a long-term storage lagoon like this, you have to use a backhoe to get them out and everything else. The nice thing about our vegetative treatment areas, where we pump them dry, is you go in there once or twice a year with a tractor and box scraper or a tractor and loader, and you scrape the solids out and apply them, load them up in a dry fertilizer spreader, apply them farther away. Anytime you can handle manure as a dry product, it has a lot more value. There have been a couple of systems designed, vegetative treatment areas designed for North Dakota.
Okay.
They have never gone in.
Really?
But they have been designed.
Do you know why they didn't go in?
Personal opinion, and I've seen this all over, is, okay, we have a problem. There's never been a good solution. There is a good solution now, but as long as we say we're looking and we're working on a project, we can delay it. I fed cattle for 20 years. I knew I had a runoff problem. Every year I went down to the NRCS office and I signed the form saying that, hey, we have this problem, we know it, but since you don't have a solution, we'll ignore it. Well, as long as you're following the paperwork. When the day comes when fines are imposed, things will change. That's the point you guys as producers need to realize. Your DEQ has a hard time fining. EPA has a very easy time fining. If you can keep the EPA out of your state, you're going to be a lot better off as smaller producers. But to keep the EPA from coming in, you have to show, your state has to show that it is doing practices and doing things to improve it. You also have to realize this is all part of the Clean Water Act. In 1972, this is when the Clean Water Act came out. They've mainly gone after industries. But as technology is advancing, as we're cleaning up, we have farther to go.
Right now in North Dakota, we still work with our Department of Health, Division of Water Quality, and those guys up there are great to work with. The EPA does come in and do a week-long inspection. They spot check certain places in North Dakota. And so I couldn't have said it better myself. If we can keep them out of our state by doing things correctly now, we're going to be way better off in the future. We're not telling you to go home and dig ponds or spend hundreds of dollars that you might not have, but just little changes every year to improve your environmental impact will help to keep EPA where they're at right now.
The other thing you got to realize is by going through your NRCS office and your extension and places like that, they're going to design you a system that meets the guidelines. So you're grandfathered in. You go out and do something even though it's better than what you did, if it still doesn't meet the guidelines, will make you change it. So it isn't a bad idea to work with these guys. In all honesty, they're here for you.